This is a how-to for looking at molarity and calculating out molarity. So I have two sample problems here. The first one says, what is the molarity of a solution with 58 grams of NaCl in 1 liter of solution? So we're looking at the concentration. How many pieces of NaCl are fit into the 1 liter? So we know that our molarity equation is molarity equals moles over volume. So I took my grams, using the molar mass, I converted to moles. So now molarity equals 0.992 moles over 1 liter, and that comes out to be 0.992 molarity. The second type of problem we have is one where we know the concentration or the amount of one solution and we're trying to change that solution. Either we're going to dilute it down or we're going to make it more concentrated. And the conversion, or in the equation we use for that, is M1V1 equals M2V2. So you just need to set which one is your M1 and which one is your M2. So I'm going to say that this concentration and what I'm looking for is the ones. So we have M1 and V1. This one is what we're making, so that's V2 and M2. It is important to keep those together. So we have 250 milliliters of 6.0, so these could either be ones or twos, and in this case I've selected them as the twos, but you can't do this as V1 and this as M1 because they're not part of the same solution. These are the same solution, so we have to keep them together. So we have 18 molar times V1 equals 6.0 molar times, we can't use the 250, we have to use this conversion that I've done over here because molarity is in liters, so we need our volume in liters. So I just use the conversion of 1,000 milliliters in a liter to make this as 0.250. So that's the number I'm going to use, 0.250 liters. Okay, divide both sides by 18 molar to get V by itself. V1 equals 0.083 liters. So what I would need to do is get 0.83 liters of the 18 molar solution and put it in a beaker, a flask, or a graduated cylinder, and then add water up to 250 milliliters. And that would give me a solution at 6 molar.